Hey guys, CT Stealth here, and I'm just showing you that I received a video request and I'm answering his question. What Dr. Sardonic has asked is, do you think you could show an object being passed between parents using constraints, i.e. a box 1 picks up cone, takes it to box 2, who then takes it away? I've tried using the parent constraint to do this without success. Well, Dr. Sardonic, I'll show you how to do so. So what I have here is I've set up a small scene, and as you can see, the box here goes up and down, whereas this box over here goes left and right. So in order to create a mutual agreement for them to share this cone and be able to influence the cone, I need to set it up properly. So what I'm going to do is I'm going to just go to my selection tools, and I'm going to select the last thing. The last thing selected is the thing that's going to be constrained. So I click the box first and then the cone, and I go to constrain parent. Then I'm going to come over here, select the box here, select the cone, constrain parent. Now what I should get is I should get a mutual between the two. So like the cone itself should be balanced between the two parents that I've set. Now if I look in the cone's attributes located in the channel box under inputs, I can see the different types of the influences this cone is actually undergoing. So I'm going to click on the pcone1 parent constraint, and you'll notice I'll have a pcube1 w0 and a pcube2 w0 w1. Now what this means is this right here stands for the name of the object, and then the 1 w0 stands for the first weight, the 0 being the main influencer. These weights are considered kind of like a scale, so I can influence one to influence one or the other. Basically what it means is if these two are equal, they're going to be shared. And if this is typically a number between 0 and 1, and 0 being no influence at all, and 1 being influence at an object. So if I change this to 0, it's going to be completely influenced by the second cube here. Instead of it going up and down, it's now going left and right. Same things with if I flip these two. You'll notice that the cube will only go up and down as opposed to left and right. So what if I want them to, be shared? Well, in order to do that, first of all, these weights are what animators use a lot more often they always need to be equal to 1. If they go over it, it can sometimes get wacky. So what we do is we actually set an expression. So what I have to do is I have to go to Edit Expressions, and I select the p cube, and I'll notice this nice long name here. So I'm going to copy this and make it equal. First let me kind of make it a little bit bigger for you. Alright, and now I basically paste it. So say pcone1 parent constraint, this is equal to this. So I just pasted the same thing twice, made it equal to one another. Now what I'm going to do is I'm going to change this to match what my nodes say here. So it says p cube, that's cube 1, so I change that to 1, and that's a 0, so I change that to 0. And it's the same parent constraint, we're influencing the cone, so everything is set. Now I make sure my semicolon is inserted and I click create. Alright, so basically what this means is whatever this is equal to this. Well, I want it to be whatever this number is, I want this to be the other point. Whatever these two numbers should only equal 1. So in order to do that, it's like say, okay, 0.5, this should be 0.5. But what if this is 0.4? This should be 0.6 because it's got to equal to 1. So what I do is I just come over here to my expression, I type 1 minus whatever this is. I'm going to edit it, and you'll notice now that this is now 0.4 and this is 0.6. So now when I just type whatever, it's going to equal. Alright, so now that that's taken care of, I only have to worry about one of the weights. So now I can kind of, if you can just go through by trial and error, I can go, okay, well, 0.1, you can see it's kind of more influencing towards this cube here because the weight 2 is now 0.9. And I can influence it more towards the left cube to go up and down. and I can adjust these weights accordingly, just like so. So you can also even set some keyframes and try to get it to blend between the two. So if I want the cone to go from, let's make it go an obscure angle, like diagonally like this, set that key, go to frame 24, set it over here, so like that. Let's see what this does. Alright, 0.5, and looks like the keyframes is actually is overwriting what the constraints are being set to. And you'll notice that over here. I now have a green, basically influencer. This tells me that there's a constraint and keyframe set. That's what the green means. So what I would normally do is you need to try to avoid keyframing over animation like that. And you can actually do stuff with that, where it's like green like that. But that's it's actually more complex, so I won't really get into that. But that's basically what you do, is you influence everything by the weights. And if you have multiple weights, you configure your formula to match that. And it's actually rather simple, because a lot of times you're only influencing between 2 weights as opposed to influencing by 3. So let's just say if I had another cube here, p cube 3 weight 2, most of the time I would rarely never have all of those weights being used. It's always just between the 2, and I would keyframe between those. Instead of writing an expression, I would just keyframe the actual the between the 2 weights at the time. And you can always break the connections at any given moment too. So you can just right click and break the connections. You'll no longer have that expression, and it's not equalizing to be whatever you want it to be, but at least then you can keyframe the actual animation. So I hope that helps, and if you have any questions, feel free to ask. Thanks for watching, and thank you for your question.